All right, welcome back to part 2. Sorry about that, guys. Technical difficulties. Let's work through the last two examples together. Example 4 says solve and graph the solution on a number line. Okay, so if I'm going to solve and graph this solution, what I need to do is I need to go back to my definition of absolute values one more time. Okay, so this is saying that this is some distance is greater than 13 on a number line. Does not matter which direction, right? It does not matter which direction. So what I'm going to do is I'm going to consider both the positive and the negative. If I consider the negative, I have to flip my inequality because in the negative directions, bigger is actually smaller, right? So it goes back to all of that. I know that can be a little bit confusing to people. Don't worry if you're a little bit confused. I could try to work a little bit more with you on that if that is the case. But let's go ahead and try this. Okay, so the distance, let's look at the positive distance first. So 4x minus 7 greater than 13. And then we also want to look at the negative distance. Okay, and again, there is no such thing as a negative distance. We're talking about the distance to the left, right, in the negative direction on the number line. So we're going to also consider this guy where we flip the inequality and change the sign, right? So we're looking at things from the negative direction as well. Okay, so I'm going to add 7 to both sides. So I get 4x is greater than 20, x is greater than 5. And then I'm going to add 7 to both sides on this one. And I get 4x is less than negative 6. And then x is less than negative 6 over 4. Which reduces to x is less than negative 3 over 2, or negative 1.5. Okay, so I put this on the number line. Okay, it says x is greater than 5. So let's call this 0, 1, 2, 3, 4, 5. We'll put an open circle there. Okay, it says x is greater than that, so we're going to go this direction. And then it says x is less than negative 1.5. So here's negative 1, negative 2, negative 1.5 is here. And it says less than, so we're going to go this direction. Okay, so whenever we have a distance that is greater than something, it's an or statement and things go off in either direction because the distance over here is greater than the distance, closer in to 0. So just remember, whenever you have a greater than sign, it's going to be an or statement. Okay, and then for part B, for B, this is a less than sign. So this is going to be an and statement. Okay, so things are going to kind of go in between two things. Okay, so let's solve this one. So we have 5z plus 2 is less than or equal to 17. And then we also have to consider the other direction. So 5z plus 2 is greater than or equal to negative 17. Okay, so let's solve these. We're going to subtract 2 from both sides here. We have 5z is less than or equal to 15, so z is less than or equal to 3. And then we also have on this side, we're going to subtract 2 from both sides just like we did there. We have 5z is greater than or equal to negative 19. And then we have z is greater than or equal to negative 19 over 5. Okay, negative 19 over 5. If I change that to a mixed fraction just to get a better idea for where that is on a number line. 5 goes into 19 3 times. Okay, and then I have 4 left over. So it's negative 3 and 4/5. All right, or negative 3.8 if you prefer. So if I'm going to graph this on the number line, okay, we're saying that z is less than or equal to 3. So here's 0, 1, 2, 3. Okay, so we're going to go at 3, we're going to go this direction. And then at negative 3 and 4/5, negative 1, 2, 3, 4, negative 3 and 4/5 is somewhere in here. We'll have a solid circle in there as well. And it's saying that z is greater than that guy, which is going this direction. Okay, so that is an and statement where it's saying that the distance is less than this is saying some distance here between 5z plus 2, that distance is less than or equal to 17. Okay, so when we simplify it all down, we get these two numbers, but since it is a distance that is less than, it's going to be an and statement, and so it's going to look like this. Okay, this is -4, -3, it's somewhere in there. Okay, sorry, that might be a little bit confusing still, but just remember, if a distance is less than something, it's an and statement, because it's saying, you know, the distance from 0 is less than some number in either direction. If it's greater than, it's going to go off in either direction to infinity. Okay, for example 5, and then we'll be done. It says Rachel is considering colleges to attend and determines the average tuition among her choices is $37.25 per year, but the tuition at a school could differ by as much as $16.50 from the average. Write and solve an absolute value inequality to find the range of tuition. Okay, so for this one, you guys, first of all, the easiest thing here is probably to figure out the graph and the answer to this before we even to write. Like, the hardest part of this will probably be to write the absolute value problem, because we know, we kind of can figure out, like, common sense, the solution here. If my average is 37.25, but it can vary by as much as 16.50, doesn't that mean we could, you know, we could have 37.25 plus 16.50, or we can have, you know, all the way down to 37.25 minus 16.50. So there's this range, right? So the middle number is actually 37.25, and I can go this way 16.50, and I can go this way 16.50. Okay, so right away there, I'll do the math for you just to make this fast, but that would put me somewhere over here at 5,375, or in this direction it would put me at 2,075. Okay, I'm just subtracting 16.50 from this and adding 16.50 to that. Okay, so that's like my range. The tuition can range all the way from here to here. So that part's easy, but they said they want us to write and solve an absolute value inequality to find this range. Okay, so again, if you just wanted to find the range, that's probably how I would do it. But since they want us to go back to like what we know about absolute values, we can do that. Okay, so the middle number here, okay, the distance that we're talking about is from 37.25. Okay, and we know that it's a difference, and we know that the difference has to be less than 16.50. Okay, so that's an and statement, right? So if it's an and statement, it's a less than statement. So we know it's going to be less than or equal to 16.50. Okay, this is the hard part. So since it's plus or minus, right? Since it's plus or minus, that's considered an absolute value. Okay, so the tuition, the difference in tuition is, and the difference from the tuition that we determine and the average is what we're looking at, is less than 16.50. So if we just call tuition T, okay, the tuition minus 37.25 has to be less than or equal to 16.50. Right, that's my absolute value. And if you remember from what we did in Algebra 1, which is, I know it's been a while, but when we designed some of these things, remember that whatever goes in here is what makes this thing go to 0, right? So if I plug this 37.25 in for the tuition, that would be 0, right? So if that does not make sense to you, don't worry about it too much. I will review that again. But yes, we're looking at a distance from the average cost of tuition. Okay, so difference of the average cost of tuition, so difference is subtraction. And it has to be less than 16.50. So that's why I did less than or equal to 16.50. Okay, so there's my absolute value. That's what it looks like on the number line. If I go to solve it, it would be something like this, where since it's an and statement, T would be in the middle. Okay, and the range is 2075 to 5375. I believe we include those numbers. Okay, so if they want the inequality, the and statement, there it is. All right, guys, so you have one like that. It'll be a little bit of a challenge. Don't worry too much if it's causing you a lot of stress with this one of these word problems. Don't worry, we'll do this together in class at some point when we get back together.